Chapter 3, Section 5, Applications of basis and basis vectors in feature selection. Basis and basis vectors are abstract concepts, so it may be difficult to see their usefulness. In the previous video, I mentioned that a basis can be applied to feature selection. This section aims to clarify how the concepts of basis and basis vector are related to feature selection. One of the critical issues in developing a machine learning model is determining which features in a dataset are truly important and which can be ignored. This is the issue of feature selection. In machine learning, features can be regarded as vectors in a high-dimensional space. The concept of a basis makes it possible to identify which features are redundant and which provide unique and meaningful information. Let's start with a recap of the basis. A basis is a set of vectors that are linearly independent each other and span a vector space. A basis vector is one of the vectors that make up the basis set. The basis vectors are the building blocks of the vector space. We can recreate any point or vector in the space using just these few basis vectors. Since the basis vectors are independent of each other, each basis vector represents a unique direction in space. So, using basis vectors, it is possible to cover all directions in the space. As an example, let's consider a simple two-dimensional space. In a two-dimensional space, the vectors 1, 0 and 0, 1 are considered to be the basis vectors. They correspond to the x-axis and y-axis respectively. And any point in a two-dimensional space can be expressed as a combination of these two vectors. For example, the point 3, 2 can be expressed in this way. In other words, it is possible to represent the entire two-dimensional space using just these two vectors. Now, let's relate the concept of basis to feature selection. In machine learning, the features can be considered as vectors in a high-dimensional space called a feature space. In feature selection, we identify important features. And what we are actually doing here is selecting the correct basis that represents the most important dimension in the data. This enables us to remove redundant features while retaining important information. The basis indicates whether or not each feature is independent. This also means that we can distinguish between features that provide unique information and redundant features that do not provide unique information. Redundant features do not add any new information to us, but simply represent what is already known from other features. The concept of basis is useful for distinguishing between such features. Let's consider a simple example of redundant features. Here are three vectors, v1, v2, and v3. At first glance, these look like different vectors. But if you look closely, you'll see that v2 and v3 are just multiples of v1. In other words, all the information provided by v2 and v3 is already provided by v1. Therefore, the information contained in all three features can be expressed using just v1. In other words, v2 and v3 are redundant, and the important information is not lost if these are deleted. When depicted as a diagram, the three vectors are related in this way. You can see that they are different lengths but point in the same direction. The basis is the minimum set of vectors that can express the entire space in independent directions. It is important to select only the minimum number of features necessary to express the data, that is, only features that are the basis. This enables us to eliminate redundant information and maintain the most important dimensions of the data. The role of basis vectors in feature selection is to make the model simple and efficient. By removing redundant features, we can reduce the computational cost and prevent overfitting. In addition, representing data with a small number of bases also improves the interpretability of the model. It is because we can represent the relationship between predictors and outcome more simply. Thank you for watching. Please thumbs up and subscribe to my channel.